Welcome back. Today we're going to talk about constructing a confidence interval for P1 minus P2. So this would be a difference of proportions. And so when we start to go about actually constructing this interval, there's some considerations that we need to take. We're going to use our state, plan, do, conclude model, and we're going to talk about what exactly a certain type of interval might mean. So here we go. Confidence interval for P1 minus P2. And this is going to be a box that's divided into two, but it's going to be about 2/3 and 1/3. First thing we're going to do is we're going to talk about our state. So what are we stating? We are doing P1 minus P2, which is the difference, the true difference in proportions. And our plan is going to be a two-sample Z interval for P1 minus P2. And this is going to be something we need to kind of keep our eye on. Which test are we doing and which interval are we making? So a two-sample Z interval, you can remember that because we have a difference in proportions. So that's our two-sample from our P1 and our P2. And then our Z interval is because we're dealing with proportions. In order to do this, we need to check our conditions. So our first one that we check is independent random samples. Our second condition is our 10% condition, so checking to make sure that that is true. And number three, we want to check for large counts to see if it's normal. If all three of those are true, we can go ahead and do our interval. And to construct our interval, we write out our general formula, our point estimate plus or minus our margin of error. And our specific formula for that is P hat 1 minus P hat 2 plus or minus our Z star times our standard error, which is P hat 1 times 1 minus P hat 1 over N1 plus P hat 2 times 1 minus over N2. Okay? And our conclude is that interpretation that we've been talking about where we have that direct quote, we are 95% confident that the interval between here and here captures the true mean number of, and then making sure that we have our context. So those four things are things that we've talked about in the past, but we want to make sure that we have this grasp of laying them out in order so that we can make sure that we do them. So you want to make sure you say, this is what I'm doing. Here's my plan of what I'm going to do. I check my conditions. I actually do the mathematics, and then I interpret it. We're 95% confident that the interval from captures the true mean number of, or the true proportion of something, okay? So do we have convincing evidence? So what is convincing evidence? And that's going to be our focus over here, convincing evidence. So if we have an interval that has two positive numbers, that means that our first proportion is greater. Well, what does that mean? That means when we do a subtraction problem, right? So P hat 1 minus, or so P1 minus P2, P hat 1 minus P hat 2. If both of the interval options are positive, then that means there's no chance that the second one is bigger. If we have a positive, let's go this way. Let's go negative first. If we have a negative and a negative, then that would mean that the second proportion is greater. Because the second one is bigger, which would yield a negative number. But if we have this positive and a negative, actually it would be a negative positive, right? Because we're going to list it in order. So negative, positive. We have no convincing evidence of a difference. And the reason is because it contains 0. So it's in this interval that contains 0, so therefore we don't have convincing evidence of a difference because it could be 0. Let's do an example, and I think you'll see how this all comes together. Okay, so in this Check Your Understanding, we're going to read the prompt. My encouragement to you, as always, is to pause it and try it on your own and then come back and see the commentary that I have about it and see the right answer. So, in a social study, a random sample of 150 teachers were selected and an independent random sample of 100 nurses were selected. Each person was asked if they currently have a second job. The results showed that 48 of the 150 teachers and 21 of the 100 nurses had a second job. Construct and interpret a 95% confidence interval for the difference in the proportion of all teachers and nurses that have a second job. So, in this particular state, plan, do, conclude, notice I have state, plan, do, and conclude. I've laid out some additional cues for you to know what to do. And so let's go ahead and step through this example and talk about what are we actually doing in each of these steps. So first, what is our parameter? Well, P sub t minus P sub n is going to be the true difference in the proportion of all teachers and nurses that have a second job. And just to be clear, I like to outline this. P sub t minus P sub n means teachers minus nurses. Okay, so that's the order that we need to go in for that. And so what is our confidence level? We are going to be estimating this at a 95% confidence level. And again, that's so that we can determine our Z that we're going to be using. And so that's going to be a Z star. And we know that we're using Z star because we're talking about proportions. So that's going to be a Z star equal to 1.96. And up here in the state portion, I also like to list out exactly what's going on with our proportions so that way I can reference those numbers later. So P sub t is going to be the proportion of teachers who have a second job. So that would be 48 of 150, which is equal to 0.32. And this is actually a p hat. So the p hat sub n is equal to 21 out of 100, which is 0.21. So therefore, p hat sub t minus p hat sub n is equal to 0.38 minus 0.21, which is equal to 0.11. So in our anecdotal sample, we have a difference of 0.11. What we're trying to figure out is that, how does that, like, what do I do with that? Like, if that's my sample difference, what is my overall difference in my populations? So my plan is to do a 2-sample Z interval for P sub t minus P sub n. And when we check our conditions, we want to check 3 things. Is it random? And since we're dealing with 2 samples, we need to check both of them. And our 10% condition. And since it's 2 samples, we need to check both of them. And we want to check if it's normal by using large counts. And because it's 2 samples, we need to check both of them. So we're going to be doing a lot of checking here, and this is going to be a common theme when we're doing these tests, and we're going to have to do a lot of work before we can actually do the math. So, are they independent? Random samples. Let's look at the prompt. So, a random sample of 150 teachers were selected and an independent random sample of 100 nurses. So, yes, so we have in quotes a random sample of 150 teachers. And we have a random sample of 100 nurses. So I'm going to give that a yes and a yes. Let's check our 10% condition. 10% condition is 150 less than 1/10 of all teachers is 100 less than 1/10 of all nurses? The answer to those two questions is obviously yes. So we need to check both of them. And then for our normal, this is actually going to involve us checking four things, because as you remember with proportions, we need to check both successes and failures, meaning we're going to do 150 times our known proportion. And we want to check, so that's 48, and we are measuring that, is that greater than or equal to 10? And then 150 times 1 minus 0.32, which is 0.68. And that's equal to 102, which is also greater than 10. So for the teachers, we're good. Then we're going to measure our nurses. So is 100 times 0.21 greater than or equal to 10? The answer is yes, because it's equal to, let me do it in the same format. It's equal to 21, which is greater than or equal to 10. And then 100 times 0.79 is equal to 79, which is also greater than or equal to 10. So kind of notice what I did here is I very systematically said I need to check these 1, 2, 3 things, and I checked both conditions, or so teachers and nurses, teachers and nurses, teachers and nurses here. So now I can actually do. So I did all that work. Everything is laid out. Now I can actually do the problem. I can actually do the mathematics. So my general formula for a confidence interval is my point estimate plus or minus my margin of error. And on your sheet for AP Statistics, the formula sheet, this general formula is on there. When we do the specific formula, we're going to have p hat sub t minus p hat sub n. And that was the difference that we found above here, right? So that's our 0.11. And we're going to have plus or minus z star times, and this is where our big formula comes in, p hat sub t, 1 minus p hat sub t over n sub t, plus p hat sub n times 1 minus p hat sub n. And you're going to see that this comes together really, really quickly. And that's n sub n. Well, check out what happened here. I actually did a lot of this work already, which is kind of cool. We lay it all out. So I have p hat sub t minus p hat sub n. I have my z star. I actually have my numbers here, right? So I actually have my values. Ooh, that's not good. Wait, give me a minute. So I actually have my values here that go into my formula up top. And I know my numbers from up above. So all I'm doing basically is just plugging in numbers that I've already been laying out all along here. So I have 0.11, which is my difference, p hat sub t minus p hat sub n, plus or minus 1.96 times the square root of, and I've got 0.32 times 0.68 over 150, plus 0.21 times 0.79 over 100. And all those values came from up above. So I've got 0.11 plus or minus 0.109 is what comes out of that. And so my interval that yields here is 0.001, comma 0.219. Now notice what our result interpretation looks like up here. So we had 3 options, right? So we had plus, plus, minus, minus, or plus, minus. And only one of them gave us the ability to say we have convincing evidence that there is no difference. And if you think about it, to have no difference literally means when you subtract them, it's 0. So is 0 a possibility? Well, look at our interval here. So check it out. So just think about that in terms of what the implications of that might be. Our conclusion, however, is going to take this form of, this we are 95% confident and so on and so forth. Let's do that conclusion here. We are 95% confident that the interval from 0.001 to 0.219 captures the true mean difference so that's our first part. Now we have the context. In proportions of teachers and nurses that have a second job. And I'm going to quantify this a little bit or qualify it. So, and that's going to be teachers minus nurses. Okay, just to be clear. All right, so let's review what we did here. Up top, we talked about our 4-step process: state, plan, do, and conclude. And we talked about stating our true difference in proportions here. Our plan was to do a 2-sample Z interval for p hat 1 minus p hat 2, and that was a Z because we're doing proportions here. We check our 3 conditions: independent random samples, 10% condition, and large counts. We need to do that for both P1 and P2. And once we verify those conditions, we've laid everything out to do the do. So we write our general formula, point estimate, plus or minus the margin of error. Here's our point estimate as given from our prompt, times our Z star, which is determined by our confidence level. And then we use our standard error formula. I want to point that out pretty clearly here. So this is our standard error formula, which is essentially our standard deviation, and that's on your formula sheet underneath 2 proportions. And then our conclusion comes in the form of that prompt. We are 95% confident that the interval from our plus or minus where we calculated contains the true interval, and then make sure you have your context. So when we determine convincing evidence, we say if we have an interval that has 2 positives, then the second one is smaller than the first one. So the first proportion is greater, meaning anytime you subtract, the first one's the bigger one because you don't get to negatives. If they're both negative, it means the second proportion is greater because you're subtracting more than you had. And if you have this plus minus, this is the sweet spot where we have an interval that contains 0. So there's evidence that there could be there is evidence that there could be no difference. Then we did this example where I stated p hat or p sub t minus p sub n is the true difference in the proportion of all teachers and nurses who have a second job. I laid out what my proportions were from my prompt, and those are it's gonna allow me to use those later down here in my formula, right? So I've got down here, I use those in the formula. And by finding the difference here, we're saying, hey, here's some evidence. Is it convincing? Well, I don't know, but there seems to be a difference here. Laid out my 2-sample Z interval for p hat sub t minus p sub n, or p sub t minus p sub n. I checked my 3 conditions. Important checking to see that it was true for teachers and nurses. Teachers and nurses, normal counts for teachers and nurses. So I have to check for both proportions that it's true. Specific or general formula, point estimate plus or minus margin of error. Specific formula. And the cool thing is I started to highlight here, right? So I started to highlight the fact that I already laid out my Z star. I already laid out my point estimate. I already laid out all of the proportions that I need to plug into my formula up here and then up here. Found my confidence interval, and then I concluded that it was 95% confident that the interval from 0.001 to 0.219 captures the true mean difference in proportions of teachers and nurses that have a second job. All right, so guys, that's the basics of constructing a confidence interval for P1 minus P2. I hope you enjoy.